NASA hit the jackpot this week. The holy grail of planetary research is to find flowing liquid water, which can one day perhaps sustain life. NASA has announced new evidence of flowing water on the surface of Mars. The dark streaks in the image provided are believed to be liquid, extremely salty water. The NASA rover, dubbed Curiosity, keeps coming up with startling new discoveries on Mars. This time, the rolling lab may have stepped right into an ancient riverbed. How much of a discovery is this? First and foremost, I'd say it's another piece in the puzzle of what Mars used to be like. It confirms earlier speculations that there must have been liquid water and rivers. The age-old question, is there life beyond Earth, may have taken a giant leap forward with NASA's announcement of this extraordinary discovery: liquid water oceans beneath the surface of Mars. While evidence of water in the form of ice or fleeting surface flows has been observed in the past, this marks the first time scientists have confirmed the presence of vast, stable liquid water reservoirs on the red planet. This breakthrough could reshape our understanding of Mars and its potential habitability, opening new doors to exploration and fueling our quest to find extraterrestrial life. NASA's latest findings result from decades of meticulous research and technological advancements. The search for water on Mars has been one of the primary goals of Martian exploration. Early missions, such as the Mariner and Viking programs, hinted at a planet that once had a wetter and more hospitable climate. Later orbiters like Mars Odyssey and Mars Express detected evidence of subsurface ice and hydrated minerals. The Curiosity and Perseverance rovers have since uncovered traces of ancient riverbeds and deltas, reinforcing the theory that Mars once had vast bodies of water. However, it wasn't until the deployment of the Mars Reconnaissance Orbiter, MRO, and its radar instrument, SHARAD, shallow radar, that scientists began to suspect the existence of subsurface liquid water. These suspicions gained traction in 2018 when radar data suggested the presence of a liquid water lake beneath the southern polar ice cap. Still, the evidence was inconclusive, sparking debates within the scientific community. Fast forward to 2025, NASA's revolutionary discovery is credited to a new generation of instruments aboard the Mars Ice Mapper (MIM). Launched in 2028 as part of a collaborative effort involving NASA, ESA, and several other space agencies. Equipped with high-resolution radar systems capable of penetrating deeper into the Martian crust, MIM has provided unambiguous evidence of massive subsurface oceans spanning hundreds of kilometers beneath Mars' northern lowlands and southern polar regions. NASA's analysis of the data reveals that these underground oceans are not mere pockets of water, but extensive reservoirs potentially comparable in volume to Earth's Arctic Ocean. The water is situated several kilometers below the surface, insulated by layers of rock and ice that prevent it from freezing, despite Mars's frigid surface temperatures, which can plummet to -125 degrees Celsius -193 degrees Fahrenheit at the poles. How is the water staying liquid? The presence of liquid water in such extreme conditions may be attributed to a combination of factors, including salinity, geothermal heat, and pressure. Similar to Earth's deep-sea brine pools, the water on Mars is likely rich in salts, particularly perchlorates. These salts significantly lower the freezing point of water, allowing it to remain liquid even at sub-zero temperatures. Mars' interior still retains residual heat from its formation and radioactive decay, providing enough warmth to sustain liquid water beneath the surface. The weight of the overlying rock and ice exerts sufficient pressure to keep the water in a liquid state. This unique environment presents a tantalizing analog to subsurface oceans on icy moons like Europa and Enceladus, which are considered prime candidates for hosting extraterrestrial life. The discovery of liquid water oceans on Mars has profound implications for astrobiology. On Earth, liquid water is a fundamental prerequisite for life as we know it. Even in the most extreme environments, such as hydrothermal vents, subglacial lakes, and highly saline brine pools, life finds a way to thrive. Could the same hold true for Mars? The underground oceans could provide a stable, protected environment for microorganisms to survive. The high salinity and potential presence of energy sources, such as geothermal heat or chemical gradients, mirror conditions where extremophiles thrive on Earth. If life ever arose on Mars, these oceans might serve as its last refuge. Even if life no longer exists, the oceans could contain biosignatures, chemical or physical evidence of past life. Detecting these would provide irrefutable proof that Mars was once a living world. The discovery underscores the universality of water as a cornerstone of habitability. It reinforces the idea that other celestial bodies with subsurface oceans, such as Europa, Enceladus, and Titan, may also harbor life. NASA's announcement is a game-changer for the future of Mars exploration. The next logical step is to directly access the underground oceans. This will require advanced drilling technology capable of penetrating kilometers of rock and ice. NASA and its partners are already developing such systems, with concepts like the Mars Ice Mole and Cryobot being adapted for this purpose. Instruments designed to detect and analyze organic compounds, isotopic ratios, and microbial life will play a central role in upcoming missions. These tools will help scientists determine whether Mars's oceans are merely reservoirs of water or cradles of life. The presence of liquid water makes Mars a more viable candidate for human colonization. Access to water is critical for life support systems, agriculture, and the production of oxygen and rocket fuel. Subsurface oceans could serve as a sustainable resource for future Martian settlements. The discovery raises important ethical and scientific considerations. Any missions targeting the subsurface oceans must adhere to strict planetary protection protocols to avoid contaminating potential Martian ecosystems with Earth-based microbes. While the discovery is groundbreaking, significant challenges remain. Accessing the subsurface oceans will require innovative engineering solutions, and developing and deploying such technology on Mars' harsh terrain is no small feat. Ensuring that Earth organisms do not contaminate Martian environments is a top priority. This requires sterilization techniques that balance planetary protection with scientific objectives. Differentiating between abiotic and biotic processes in the oceans will be a complex task. For example, certain chemical signatures could result from geological processes rather than biological activity. As space exploration becomes increasingly global, coordinating efforts among nations and private entities will be essential to maximize scientific returns while minimizing duplication of efforts. The discovery of oceans on Mars is not just a scientific milestone. It is a moment of profound philosophical and cultural significance. It challenges us to rethink our place in the universe and the uniqueness of Earth as a cradle of life. For centuries, humans have gazed at the night sky and wondered whether we are alone. This discovery brings us one step closer to answering that question. Moreover, it reinforces the importance of preserving and understanding our own planet. As we uncover the secrets of Mars, we are reminded of Earth's fragility and the need to protect its ecosystems. Mars may offer insights into planetary evolution and climate change, shedding light on how to address similar challenges on Earth. NASA has already announced plans to accelerate its Mars exploration program in light of this discovery. Some upcoming milestones include the Mars Subsurface Explorer mission in 2028, which will deploy a robotic drilling system capable of reaching the oceans. It will be equipped with advanced analytical instruments to search for life and study the ocean's composition. Human missions to Mars are also planned for the 2030s, with NASA's Artemis program, aimed at returning humans to the Moon, seen as a stepping stone to Mars. The discovery of water oceans strengthens the case for human exploration, as astronauts could play a critical role in conducting in-depth research. Collaboration with private industry, such as companies like SpaceX and Blue Origin, will be crucial in developing the technology needed to explore and utilize Mars's resources. NASA's discovery of liquid water oceans on Mars marks a historic moment in the annals of space exploration. It is a testament to human curiosity, ingenuity, and determination. As we stand on the brink of answering one of humanity's most profound questions, are we alone in the universe? This discovery fuels our imagination and drives us to push the boundaries of what is possible. Mars, once thought to be a barren wasteland, has revealed itself as a dynamic and complex world with the potential to harbor life. The journey to explore its oceans and uncover its secrets is just beginning. The next few decades promise to be an exciting era of discovery, collaboration, and innovation as humanity takes its first steps into the depths of the Martian subsurface. In the words of Carl Sagan, somewhere, something incredible is waiting to be known. that something might just be beneath the icy crust of Mars, waiting for us to find it. The discovery of liquid water on Mars is not just a milestone in the search for life beyond Earth, but also opens up significant avenues for future exploration. In the coming years, the quest to understand the Martian subsurface will likely expand with advanced robotic missions and potentially even human expeditions. These missions will focus on uncovering the deeper layers of Mars, seeking to understand how these subsurface oceans formed, how they have been preserved, and what potential they hold for sustaining life or offering resources for future colonization. One of the immediate challenges for scientists will be to determine the full extent and distribution of liquid water beneath the Martian surface. Despite the breakthrough discovery, much of the subsurface remains unexplored, and the precise location of these oceans is still a subject of ongoing research. The presence of multiple layers of ice and rock over the oceans also poses an obstacle to direct observation. Future missions will need to deploy highly specialized equipment capable of penetrating these layers, providing insights into the deeper geologic history of Mars. With new radar technologies and drilling techniques, scientists aim to collect data on the chemical composition, salinity, and other factors that determine the water's ability to support microbial life. As technology advances, the exploration of Mars is expected to include more sophisticated techniques, such as autonomous rovers and landers equipped with advanced sensors that can analyze the chemical makeup of Martian water directly. For example, the development of high-tech drills capable of reaching down to the depths of these oceans will play a crucial role in these efforts. In addition to analyzing the liquid water, missions will likely focus on identifying potential sites for long-term human habitation, where underground water could provide essential resources for drinking, farming, and generating oxygen. In this regard, the discovery of water significantly changes the narrative surrounding the feasibility of human life on Mars. Previous models of Mars as an inhospitable world were largely based on its cold, arid surface conditions. However, the presence of liquid water beneath the surface suggests that Mars may be more Earth-like than previously thought. It opens up possibilities for terraforming or modifying Mars' environment to make it more suitable for human settlers. The discovery has already sparked debates on how humanity might use the Martian subsurface water to support sustainable colonies, allowing for the production of essential resources like food, water, and fuel. Additionally, extracting water from underground sources could provide a viable option for astronauts and settlers who may spend long durations on the planet, reducing their dependency on Earth-based supplies. Beyond the potential for human colonization, the discovery of water on Mars also highlights the importance of preserving Mars as a pristine environment for scientific investigation. The implications for planetary protection are significant, as the introduction of terrestrial organisms or contaminants could interfere with scientific research and possibly jeopardize the integrity of any potential Martian ecosystems. Strict planetary protection protocols will need to be established to safeguard against contamination, ensuring that any potential Martian life forms or biosignatures are not destroyed by human activity. This presents an ethical dilemma for scientists, as exploration needs to balance curiosity with responsibility to avoid altering the Martian environment. Another fascinating aspect of the discovery is the opportunity to learn more about the history of Mars itself. The presence of liquid water beneath the surface could offer vital clues about the planet's past. It suggests that Mars may have once had a much warmer and wetter climate, with stable bodies of water on its surface. This raises questions about why Mars transitioned from a more habitable environment to the cold, arid world we see today. By studying the conditions that allowed water to persist beneath the surface, scientists hope to gain insights into the planet's climatic evolution and how planets undergo significant changes over time. This information could also help scientists understand the mechanisms that drive climate shifts on Earth, potentially offering solutions to some of the challenges we face with climate change. Additionally, the discovery of water on Mars could have profound implications for our understanding of the wider solar system. If Mars harbors subsurface oceans, it increases the likelihood that other celestial bodies in our solar system, such as Europa, Enceladus, and Titan, may also have similar environments. These moons of Jupiter and Saturn are already considered strong candidates for harboring life due to their subsurface oceans. The presence of liquid water on Mars strengthens the possibility that life could exist elsewhere in our solar system, expanding the search for extraterrestrial life beyond the confines of Earth. As scientists continue to search for habitable environments, this discovery serves as a reminder that life may not be confined to our planet alone. Furthermore, the potential for life on Mars may lead to new avenues in the field of astrobiology. The search for microbial life in the Martian oceans could yield important insights into the origin of life itself. If life ever arose on Mars, it could offer a window into understanding the processes that lead to the emergence of life in the universe. The discovery of life, or even the evidence of past life, on Mars would have profound implications for our understanding of biology, evolutionary processes, and the conditions that make a planet suitable for life. In the long run, the discovery of water beneath Mars offers exciting opportunities for further scientific and technological advancements. While the road ahead is challenging, with numerous technical and ethical considerations, the potential benefits are immense. As humanity moves closer to understanding the history and future of Mars, this discovery serves as a catalyst for exploration, collaboration, and a broader understanding of the universe. Ultimately, it may help us answer one of the most profound questions of all. Are we alone in the universe?